Welcome everyone to today's webinar titled Getting Maximum Value from Your Operational Data, where we are discussing key organizational and technology trends facing industrial companies on their digital transformation journey. My name is Juanita and I'm a member of the marketing team at Element. Some quick housekeeping items before we begin. We've shared some helpful links in the chat window. Feel free to copy them before the end of the session, which will run for 45 minutes, including Q&A. At any point during the presentation, if you have a question, please type it in the question panel, and we will answer it during Q&A. As always, we are recording, and we'll share the link with you after today. And now, let me introduce our two speakers, starting with Joe. Joe Perino is a principal analyst at LNS Research, where he focuses on industrial transformation and operational excellence. He began his career as a process engineer in refining, chemicals, and pipeline sectors, and spent some years in sales, marketing, product, corporate development, M&A, and management consulting. Joe has worked at companies including Phillips Petroleum, Emerson Process, and IBM, among other organizations. He holds a BS in chemical engineering, a Master of Science in Finance, and has completed executive programs at the Kellogg School of Management and Harvard Business School. Welcome, Joe. How are you today?
Very good. Thank you, Juanita.
Thank you. Andy Bane is the CEO of Element, where he oversees the vision, strategy, and growth of the company. He's a veteran in the industrial sector and has held executive roles at leading software companies, including EVP and Chief Strategy Officer at ABB Enterprise Software, EVP of Product Management and CMO at Ventix, and SVP of Product Management and Marketing at P2 Energy Solutions. Andy holds a BA from the University of Colorado Boulder and lives in California with his family. Andy, welcome. How are you?
Hi, Juanita. I'm doing great. Thank you.
Thank you. And now let me turn it over to Joe.
Thank you, Juanita. So to set some context for today's discussion, I thought we'd first talk about operational data challenges. And you can see the list on the left, starting with connectivity, data access and democratization, giving access to everybody, data conditioning and contextualization, which is a very important sector. Andy will talk more about that. Data storage, persistence, synchronization. Very importantly, providing data in a format that is readily consumable by users and applications. This is a real challenge today. And then finally, if you're going to roll this out across a plant or your value chain, how do you scale this? And of course, this is connected because of the new term we hear today called data ops, which is the sidekick of DevOps. And it talks about data ops is really about getting data in a form that can be consumed by analytics. Obviously, there's more things that need to be consumed than just analytics, but getting data in the format that the user or consumer needs to make a decision or to take an action. That's the real challenge. Next slide. So why is this more complicated today? Well, this picture is meant to be an illustration of the new OT ecosystem in which you have lots of IT and OT, and in which the old ISA 95 layers are not they're no longer air gapped. So data can come in and bypass the traditional control system, going to edge, going to a historian, going to cloud, and then apps that run in the cloud, either private cloud or public cloud or vendor cloud, also can connect into here. So there's a much larger challenge in architecting this and in organizing or doing all the data wrangling associated with this, as well as cybersecurity and other issues. And what this means is that because IT has become so embedded in OT, in this ecosystem, that's prompting a convergence of process and organization, so-called IT-OT convergence. How do people then start to work together so that they co-innovate and co-engineer and co-architect this, because this takes both IT and OT to do it. And while I won't go into all of the organizational issues right now, suffice it to say there are a number of models for doing that, And we see in our studies at LNS, what we call industrial transformation leaders, they tend to do a better job of doing this, and they have more integrated teams with IT and OT. That's the direction that people are heading. Next slide. So one of the big challenges in this is, how do we get data together? Now you can bring data together at the L2 level, and by that I mean the gray and the orange on the picture. That's at the control system level, where there's probably a local historian. Then you have the issue of getting data together at the edge, and then finally you have the bigger picture of pulling the data together in an operational data cloud or data lake, and how to contextualize, organize, persist, condition, and make that data available to whatever application might be using it. A digital twin, some type of app, a BI tool, or possibly to roll up data and feed it into the enterprise data lake where you have an ERP system. So getting a handle on these types of data, which is to contextualize structured data, time series data, and unstructured data, is a real challenge. There are several ways to do that. Andy will talk about how he does it at Element in the next few slides. Let's go to the next slide. Now, LNS has actually created a use case navigator, because the question is, well, what's this worth? And the real challenge is, well, there's two challenges. One, what is it worth? And the answer to that question is, it's what you do with the data that makes it worthwhile. But the other challenge is actually getting the right infrastructure in place so that you can do something with the data and get all that ROI. And for example, we have a use case, I call it the use case wheel, where we have 6 identified groupings of use cases. In fact, we're adding a 7th, environmental, social, and governance, ESG, to this as we speak this year in LNS. And the most common use case that we typically see, very common use of analytics, is around connected assets, which means you might be monitoring, in this case, as you see in the picture, a pump. You're bringing that data in through a control system, a PLC, and then that data is stored at edge and then moved into the cloud and aggregated and organized there. And so this challenge is very common today. And one of the things that we saw in the evolution of transformation is that many people have jumped out and done pilots doing this kinds of things, connecting analytics right to the historian, or in some sort of local architecture, and then finding that when they want to scale this across the facility or across multiple facilities, they run into the problem that they haven't addressed a scalable infrastructure, a scalable architecture. And that's very important. And one of the challenges associated with that is getting your company to invest in that infrastructure, that architecture first, even though it may not have a lot of ROI, but that's step ladder to getting to where then the applications, these use cases, can then start to deliver real value and not just be point solutions at different places. Andy?
Thanks, Joe. Great overview of the realities that organizations face to maximize value from their operational data, including some of the major architectural shifts that are happening to enable those use cases you described. I mean, the use cases are where the real value begins to show up for organizations who can organize and consume their data in a way that allows them to more easily pursue as many of those 35 use cases. And now you're adding more with ESG, which is great to hear, but to pursue as many of those as possible, and to do it in a way that they can scale across as many plants, target equipment types, people, and processes as possible. I mean, we certainly see this today, where organizations desire to achieve better business outcomes through those use cases, and by deploying those modern analytical systems, whether it's BI or AI and ML, and that can really mean hundreds of analytics and apps at a single plant site. And increasingly, even data stack tools coming in, where each of those analytics apps, data stack tools, those things represented on the right here, are drilling into, repeatedly into the source systems like those listed on the left. And companies are today struggling to manage those thousands of point-to-point relationships that are cropping up between systems and analytics and applications and all the data sources. And so many of these are built with Python code and relying on spreadsheet-based data models. And not only is this costly to build, it then requires getting more and more people involved to maintain those relationships, resulting in exponential scaling and cost and complexity. And it's hard to maintain, especially as source systems grow through routine upgrades. The data starts degrading almost immediately. It can't keep up with the changes happening in the physical world and in plant operations. And so, many companies have done major data cleanup initiatives only to come back 6 months later to find that the data is already lacking in quality. And no company can come back and pay millions and millions of dollars every year to clean up their data. They've also tried to push all their data to a data lake. Many companies have tried this, and that can only exacerbate the problem because you still have to connect the data together and build context. And so, the inability to manage the data really results in an increasing number of these brittle point-to-point integrations, and results in often 90 to 95% of particularly the time series data that's generated going unused because it's disconnected from other data sources or too hard to work with. And core business systems like maintenance, finance, and process historians are often brought together, but in a very limited way. And you have many different vendors individually hardwiring into those systems of record to take just the limited data they need. And even other systems that are often only accessible to certain subject matter experts by using specialized software like monitoring systems, vibration systems, they're just too isolated and hard to work with. And though valuable, they go unused as well. So this is fundamentally, Joe, a metadata problem. You can keep the raw data flowing from one system to the next, but if it lacks context, if it's either unusable or it breaks your analytics if something changes, and it becomes ungovernable, that's fundamentally a problem of disunited metadata. And that really slows down the ability to scale use cases like those you described. Next slide, please. So to progress in the analytics journey, it really requires getting control of your metadata and your data models in a way that really provides every data consumer with an always up-to-date view of the state of affairs in operations, with what's happening around your equipment, your people, your supply chain, your products. And with Element Unify, we built a platform that sits at the intersection between multiple layers of tech, disparate sources of IT, OT data, as you described in this evolving architecture you described, Joe, which really unites those disparate sources on the left with those systems that you want to store and consume data for the analytics on the right. And our users, our customers really recognize the importance of managing their metadata and their data models increasingly separately, not just continuing to integrate at the metadata layer only, at the tag layer only, but they really need to integrate at the metadata layer, and they want a system of record for their enterprise metadata. And this is the so-called single source of the truth in their data. It's a shop-worn term. It's been around for a while, but single source of the truth is the reality, and it's very hard to achieve. And so Unify provides the glue layer that stores and represents relationships across systems. And we do this in a knowledge graph that's connected to the broader enterprise ecosystem of data sources, analytics applications, and API services that are evolving in the ever-growing enterprise data stack. So for example, you want to represent all the key attributes of, say, high consequence equipment like pumps and compressors in a more singular way across a plant or a fleet of plants, and bring context to the time series data. And that time series data may be stored in the PI system or IP21, or increasingly in a cloud native time series store. And you want to be able to represent the measurements in that time series data, attributes like temperature and pressure, with data from other systems like P&ID diagrams, so you can understand the functional location, or the work and asset management system, for work order data or personnel qualifications to work on the equipment, or the limb system to understand oil quality. And you want to bring that together with that context, that rich context together with your time series data. And so by building and maintaining relationships across all these systems, by contextualizing the metadata once, you can feed it to whatever storage and compute system or end consuming analytic or application that requires that data. And so uniting your data really means that by creating that single source of the truth with your IT/OT metadata across those source systems, without ripping and replacing anything you're running today, you're then enabled to easily create the single slice of the truth required for each and every use case, regardless of whatever system or application you've deployed. And so this means that the process team, the reliability team, the maintenance team, operators, anyone really, can all consume the same data, but in the way in which the data is relevant to them based on their own use cases. It means that you can deliver data impact where it's needed, whether in a system operating in the cloud, at the edge, wherever compute and consumption need to happen. It also means that governing your data becomes not only more important as you deploy these hundreds upon hundreds of analytics of these use cases, but it's much easier to govern at scale. Next slide, please. So let's talk about the metadata lifecycle in Unify. And so the lifecycle really starts with integrating data from sources, like I mentioned, the PI system, SAP are two big ones, but many others. And in Unify, metadata is ingested. It really happens through connectors and APIs and even just basic imports of CSV files. And we ingest and load the metadata, existing templates or data models customers may already be using, and we bring that into Unify, into the datasets catalog, which really serves now as a central repository for all the metadata templates and ontologies and datasets. And so we've now got our data to work with, and really then the next step is to contextualize that data across source systems, and to bring that metadata together and build those relationships across systems with an automated no-code pipelining capability that also has data transformations that are purpose-built for this hard-to-solve IT/OT problem. Things like tag mapping and attribute mapping that you don't find in your typical sort of ETL tools and other data tools. This Unify is purpose-built for IT/OT data and solving some of those hard problems that can then give your data a consistent vocabulary. And so a no-code approach, not only it frees you from writing Python code or using spreadsheets, but it makes it easy to extend whenever you want to add new data, because you've now got a pipeline, you've got a common vocabulary, and you can easily update it. And so once contextualized, the data then is stored in the Unify Knowledge Graph, and which provides a central store for your connected metadata, which you can then provision by configuring the data model required for a target use case, and then deploying it to the consuming system, whether that's a PI asset framework for use in the PI system and enabling things like PI Vision, or it's a JSON model for the data lake, or a dimensional schema for Snowflake. Whatever it may be, it's the same data, and you can configure and then deploy that data model to whatever system is required to consume the data. And so Unify is extensible to any system for those analytical workloads. And again, whether it's a process historian, data lake, warehouse, even a digital twin, BI tools, applications. Again, it's the idea of that central source, that source system of record for your metadata that can then be consumed wherever you need to consume it. And then last and importantly is governing your metadata in order to meet compliance obligations, but also to reduce cost, time, and friction created by using spreadsheets and Python code, really eliminating that. And so Unify is built on an events-driven reactive architecture. We persist the data in the relationships in the Unify graph. We can have live connections to source systems that can pick up changes and propagate those through and then out to the data models that are actually running the analytics. And so we're really serving as a data abstraction layer for the metadata and the data models that can be kept up to date and aligning that digital representation of assets and operations with the ground truth of what's happening in the physical world. So that's really the metadata lifecycle from and how you manage it from a unify point of departure. So let's talk about the value. So the next slide, please, Juanita, and then we can get to a summary and some questions. So, in terms of value, our users, our customers, they really are always after sort of 4 distinct values from uniting their metadata. The first is they really want to move a lot faster. They want to take friction out of the process. They want to deploy analytics much faster. And so with Unify, they're able to bring their data together and provision, configure, deploy their data models, 3 to 10 times, faster than, the approaches that they're taking today, which really then unlocks faster project execution. And then increasingly we hear about time to cache. The faster I can deploy my analytics, get things out into the field and get them running, the faster time to value I have. And so that's speed is always a big, first mover advantage that they're looking to get out of Unify. And then quality obviously is important. The being able to understand and data check, quality check your data, have better observability, and then broader usability across different functions and different users is absolutely critical to doing analytics, and keeping that then governed is the third value. And so persisting the data, reducing the maintenance cost, and really getting off of having to write a bunch of code and then somebody leaves your company and you have to go try to figure out what their code says. Getting out of code and off of spreadsheets and into reusable pipelines that can be extended, is hugely important to governing your data. And then unlocking that scale, both scale across equipment types and also plants, but then scope of use cases as well. And Joe described those 35 use cases. You can envision at a single plant, like the outtake here describing one of our customers, Evonik, where you've got many use cases that you're deploying across a single plant and then a fleet of plants. And over time, you're going to have thousands and thousands of these. And it just creates not only more silos of data, but of data models that need to be governed and of analytics that need to be governed. And you can envision a world where some of our customers will have tens of thousands of individual digital twins running, and they're going to need the governance and the quality around the data models that are really the foundation for those twins. And so those 4 values are really critical. And an element, the common thread across our customers who come out of chemicals and power generation, transmission, distribution, oil and gas, food and ag, pharma, pulp and paper. We serve a number of different sectors. They're really looking for that speed and that quality, and not unlike this article from Control Global. Evonik was able to have an experience where they were able to move fast, prove value fast, initially in 2 plants, and now they're in more than half a dozen plants and growing, with aspirations to really rinse and repeat root cause analysis, OEE, and predictive maintenance use cases for their high consequence, high value equipment across their plant sites globally. And so those tend to be the key analytical dimensions that our customers are looking for as they're bringing their metadata together: speed, quality, governance, and scale. And so with that, why don't we wrap up? Joe, take it away, and then we'll go to Q&A.
Well, I think some of these takeaways are pretty obvious to the listening audience. Number one, contextualization and governance are just must-haves for successfully using industrial data at scale. You've got to address this issue, or you're going to have a serious problem on your hands. And we realize that IT and OT professionals bring different perspectives to the world, increasingly demanding a unified approach. You can see now with the OT ecosystem that there are all kinds of architectural challenges. And in fact, to build on what Andy said, you can contextualize at the control system or historian layer. You can contextualize at the edge. You can contextualize in the cloud. And for lack of not having an infrastructure in the past, the actual analytics applications, many of these vendors are doing their own contextualization. So as soon as you start doing multiples of these things and you have a mix of it, now you're managing all these different contextualizations. It's really smart to have one. And so that's why it's important to have IT and OT come back together again and look at co-architecting this and creating this kind of universal metadata structure so that every consumer can get data the way they want to. Now, this leads us to number 4, because there's lots of ways to skin the cat. Carefully consider build versus buy. And oftentimes, especially for vendors, IT departments who want to use toolkits or Python say they can do this. And they may have done it in retail. But when you wade into the industrial data world with its different protocols and types of data and bad data and noisy data and all kinds of other things, in some cases 3-dimensional data, you're working into a different world. So I would say be very careful about thinking that you can build that yourself. And even the hyperscalers do not have a complete answer to this. So buying makes sense, but you need to buy the right thing. And then finally, given different potential approaches, data leaders need to take account of both the near-term need as well as the foundational strategic needs in choosing. And that goes back to when you approach a program of transformation, you have to put effort into the infrastructure, the foundational pieces, which then enable you to springboard and make that step change in performance and not just an incremental one. And that way you also don't fall down or, as you say, tie your shoelaces together and trip because you put in 3 things that don't scale and won't communicate. And that's a key chasm issue for people once they get away from incubating and testing to scaling, is they have to address this infrastructure portion. Let me stop at that point.
All right. Well, thank you both. Seems like any final comments before we go into Q&A?
No, let's take questions.
Yes.
Okay. Awesome. All right. I have a question here for Joe. Companies seem to be recognizing that digital transformation requires the data to be organized. You mentioned that. What are leading companies doing about their data ops efforts? Do you have some examples or comments on that?
Well, this is still an area that many of them are addressing, and I think Andy made a comment that, look at the progress Evonik's making, and hopefully that will lead to a corporate adoption so that they can solve the problem at all their plants and not just a few. Most people are in the phase of either architecting or testing these kinds of technologies for the metadata contextualization effort. And the competition there comes from not only infrastructure players like Element, but also database people like InfluxDB, the hyperscalers, mainly Microsoft and Amazon, who are the dominant players in the industrial space, and other infrastructure players that compete, as well as the DIY that you might find on the IT side. The OT side isn't really interested in DIY. They want to get a problem solved. And so they want to pick the best thing that helps them helps them solve their use case and produces real results. So I would say we're early on in this. There are no winners yet. There's no standard yet. I would say we're just crossing the chasm for companies as they start to take this up. One other comment I'll make is that these kinds of solutions have very much have IT involved in architecting this, particularly at the cloud level, and not necessarily so much OT, but it's a reason why OT needs to get involved with IT and IT with OT, so that they architect something that will work together and deliver what the end users use. The leaders in transformation are just starting to put this in right now because they realize that they need to be able to scale, and they can't scale if they don't have the right infrastructure. So I'd say we're early on, but I would say if over the next 2 to 3 years, you're going to see a lot more Evonik's on the list of people who have adopted this kind of technology and have built out their infrastructure and are starting to get real value, not just from testing one analytic on a compressor, but from literally having hundreds of these things, if not thousands of these things in play. I hope that answers your question.
Yes, it does. Thank you, Joe. I have another question, and Andy, I think you can take this one. Is it possible to manually enter values for this metadata in Unify? The reason for asking, the Pi system, for example, doesn't have an easy way for entering data for static attributes which are not linked to external systems. So the asker is saying we end up using Excel sheets for that.
Yes, yeah, great question. It is, but what I would say is what's fundamentally different is once you put in an attribute by using templates and the attributes of templates, you can get to that common vocabulary I described, and that common vocabulary includes what data label are you going to use for an attribute. And so, for example, we want to look at a certain type of pump or compressor uniformly across our plant or our fleet of plants, regardless of OEM, and here are the attributes that we want to see on that particular piece of equipment. And so we want to get that common naming scheme going, regardless of all the different data labels that are in the PI system or in SAP or in the other system. And so we work to help normalize all that and make it easier to look at equipment and processes and operations in a more singular way by allowing you to get to that common vocabulary.
Okay, thank you, Andy. Another question here. The asker says they get metadata management. How are leading companies bridging the metadata model with the transactional and real-time data? Are the metadata models imported into a data lake or some other tool for this merging of metadata and the transactional/real-time data?
Andy, why don't you take a shot, and I'll come up with some comments.
Yeah, see so when you think about how data lakes are architected and what they were trying to do, the idea was that you want to capture all the data that's streaming and then figure out what the value is later. And so when data goes into a data lake, the metadata goes to the left and the fact data or the raw data goes to the right, or however you want to describe it. They are in the metadata updates more slowly and the fact data continues to stream in and fill up. And so the fundamental problem becomes one of schema on read versus schema on write. And you need to be able to have a data model in a data lake that allows you to then make sense of whatever data you're dropping into the lake, which increasingly to in some people's opinion becomes more of a data swamp. And so the reality of what you can do with Unify is whatever model you're bringing together, for example, that where you want to say look at your time series data and your SAP PM data, you want to represent that not only say in your PI system and in your asset frameworks, but as you're then say streaming your PI data to a data lake and dropping it in there, you want to bring in your SAP data and other data as well. Well, you need a way to effectively get that model to the data lake so that you're not wasting 80% of your data scientists or analysts' time trying to wrangle the data in the lake so that you can consume it. You want them adding value. And so with Unify, we're able to get to that, both schema on read and schema on write problem with the same data and unlock whatever you're dropping into the data lake so you can quickly make sense of it. For the data scientists out there, you're also thinking about, well, I'm using Jupyter or Jupyter Notebooks or even Jupyter Hub in my organization. Well, we could connect to that, and then that is the jumping point to your data lake as well. And so there are a number of different ways that you can bring context to the data lake. I think that's, Joe, did you have anything you wanted to add there?
Yeah, I want to add some comments about architecting this, because what you've done is made an argument for why this should be an independent piece of the infrastructure and not necessarily part of some other piece. In other words, some other people have attacked this differently. They've tried to attack this by trying to look through the lens of a historian, and so they're stuck with the structure of the ISA tag asset hierarchy, which can't accommodate those other data types in the questioner's question, and which is eventually a limitation of PI and PI AF, which is why that was not done in the cloud when PI went to OCS. The other thing, of course, is I've seen some people try to do the contextualization in the visualization layer. Now you've got custom code stuck there. So you don't want to do that. You want this to be an independent piece that glues things together and then provides call it a universal handshake or the custom handshake to whatever consumer you want in there. And so this is why the ISA structure is insufficient by itself. The next way of doing it is probably to use an object model, but that also is a bit fixed because you have to predefine the objects. And then you have the graph approach. That almost sets me up with a question to Andy is, why did you choose graphs as opposed to the other methods? And perhaps the listeners would like to know that.
Yeah, good feedback there. And I will say that I'll get to the graph in just a second, but we increasingly talk about contextualize once, compute anywhere, consume everywhere as sort of the aspiration point. And you're quite right in what you said about where between sort of the historian and the data lake and the challenges there. Why a graph? The world is, these problems are very graphy problems. The relationships across people, process, technology, how things connect together, they're really not hierarchical. And we've represented data for so many decades hierarchically that it just becomes very much of a challenge to bring together all those connections, but do it in that way that is so flexible that you're able to materialize whatever view of that data that is required to deliver the use case. And so we've spent many years, and I've been at this for now almost a decade, but where we've been thinking about how can we take IT/OT data and really bring it together and connect it in a graph? So, and there's a difference between a graph model and a graph database. So we, for a long time, had a graph model in Unify, and the graph databases just weren't performant enough until more recently. And now we've got a graph database that is a very robust in-memory store underneath Unify. And so what a graph allows you to do is to maintain and persist all those connections across that represent the physical environment, that represent the people interacting with the physical environment, and have one place to persist those, Joe, and have that evergreen digital representation of reality. You can't do that hierarchically. Another reason is, and with the most recent release of Unify, just the number, the tens of thousands, the millions of connections across an enterprise, they're very hard to visualize and manage. So what is a fast way that you can give an analyst, an operator, an engineer, a quick understanding of what is the state of affairs, what is happening, and how can they come to an understanding of what relates to what, and then take that slice of the truth and go do some work on it? You can't do that in a hierarchy. You really need a graph approach so you understand what's connected to what. And so that's really and our engineering team has done an amazing job, and we're really I think the first ones who can, a graph they're very hard to build. And so one of the use cases, and you saw it on the one slide, is being able to push out of Unify into graph databases like Neo4j or Neptune, that actual graph model, so that you can then interpret the raw data in the graph. Very hard problem to solve. And so, I'm really proud of the team, and they've been at it for several years, and they've really cracked the code on this one.
All right, well, thank you for those answers. I have a few more questions. The first one is, what is the advantage of using Element as opposed to having a well-designed / templated PyAsset framework, which has the required contextualization and link to metadata values from external systems?
I can take that one and then hand it off to Joe. You're going to want to use data from many different systems, number one, and you want, PyAsset frameworks are hard to build and then hard to maintain. So doing the work of building a PyAsset framework, you want to get reusability out of that so that you can deliver the time series data to other data off takers, other consumers. And so what we're able to do out of Unify is, out of the graph, materialize a PyAsset framework that not only contextualizes the Pi data, but then SAP and P&ID data and other data. And that's typically the starting point for our customers, quite frankly, is I want to join together my Pi data and my P&ID data, and we've got a P&ID client that allows you to scrape your P&IDs and then quickly map them up with your Pi data, your Pi tags. but then bring in other rich sources of data. And so I think that is you know, an important first step, but you want that repeatable, because every time you then go to update your PyAsset frameworks, it's yet another effort, and you're using spreadsheets, and you can, you know, it's prone to manual errors. And so we've had one of our companies in the power sector, they uploaded over 200 PyAsset frameworks right into Element Unify, and then got them into, now they're in pipelines, and they're starting to enriching them with data. And so they've gotten off of Python and off of spreadsheets, trying to update and enrich and then govern their asset frameworks. And now they have a central system and a central, you know, source of the truth for not only PyAsset frameworks, but then, you know, shipping the data models off to other systems that will consume, you know, PyData. Joe?
Well, as I mentioned earlier, when OSI Soft went out to produce OCS, which is OSI Soft Services in the cloud, they did not replicate PyAF, which is basically moving PyData from the Pi server into SQL, and then moving other types of data and associating that in SQL, and then building a whole new analytics engine. When they built the cloud version, they didn't do that. In fact, they can't even import, to my knowledge, at least as of currently, they can't even import PyAF frameworks, and Unify can. So I would say to the users, be very careful on overbuilding on Industry 3.0 software, which everybody loves and it works good for what it's suitable for, but don't expect Pi and PyAF to do what Andy's Unify does with the metadata structure and the graph model. That's a bridge that's too far. So when you architect what you're going to do in the cloud and that, you need to rethink where you want your metadata connected and how you want it connected. And I think you'll find that you may not want to try to do everything only at the PyAF plant level.
Okay. Well, thank you. So last question for the day. What makes the leaders stand out when it comes to using operational data?
I can
Let me,
yeah, go ahead, Joe.
Let me start with a little bit of view from us from an industrial transport leaders. IX leaders exhibit a number of differences versus followers. One of them is that they do a lot of things. They test a lot of different things. They have a lot of things going on in an agile mode. So they test and they try and they experiment with lots of things, but they do place very few critical bets when it comes to the end. And that's number one. Number two, they have paid attention to getting this infrastructure built properly so they can scale. They know they need to do that so that they can get away from pilot purgatory, but not and piloting where they get good results and then they can't figure out how to scale it because the data model for that analytic isn't the same data model as the other analytic, and then they have another spaghetti bowl of a problem that they've just digitalized. And so they want to get away from that. So the leaders are very good at those two things. And as I mentioned, the third one is they've done a very good job of bringing IT and OT together. Typically, they integrate these teams, not just interface them. So it's almost like I'll say in general, there's some version of what I'll call manufacturing IT, which includes OT with it, that looks at what the supply chain and what the plant need. In other words, what is the highway they need to build for them to get the value out of the facility to achieve their goals: yield, throughput, conversion, energy consumption, emissions footprint, those kinds of use cases, reliability. All those things are what are driving that. So those guys have done a good job of bringing people at the table to solve that problem and not necessarily build silos of things inside and do a lot of DIY that goes nowhere. Because remember one thing about DIY, you're not buying a product, you're buying developer and data scientist time, and there's no guarantee of a product. So we have to remember and we always use the picture of the iceberg, where is the cost? Is it above or below the iceberg? When you buy a product, it's above the water level, but you know what you're getting, or at least you should know what you're getting. When it's below, you're never sure what you're going to get for sure. Andy?
Yeah, thanks, Joe. I'd say it's really, just looking at our customers, and I'd say it's three things. The first one is they're focused first on business value, and then applying the right technology and tools to achieve that, in terms of their digital transformation. And they're not trying to lead with tech. And you see a lot of folks who want to chase AI and ML, and they get some value out of it, but then they can't figure out how to scale it. And that's the pilot purgatory that Joe described. And so it's really focusing on the people in the process, the business value, and then how do you apply technology. The second thing is they're fast learners. The ones in the vanguard, and I'm talking about those who are throwing off tens of millions, if not hundreds of millions of dollars in value by deploying these use cases. Some of them are very basic, but they've been previously unachievable because they can't get to scale. But they're fast learners. They're not afraid to experiment and fail and iterate and iterate and iterate. And you hear the term increasingly that they're more agile, things like that. And so they're fast learners, and they're not afraid to fail. And then the last thing is their willingness to play in an ecosystem. And that's not only an ecosystem within their organization across IT and OT, but then their willingness to play in an ecosystem of vendors and SIs and others who are, and they're able to orchestrate together companies like our company Element and the cloud hyperscalers. We've got increasing, we've recently made some announcements of some integrations with AWS, and that's all in service of helping these companies who really at heart they want to achieve cleaner, safer, healthier, and more profitable operations from running their equipment and their processes. And so to do so and to be a digital leader, you really have to have a mentality that you're going to partner up with an ecosystem of vendors, because no single vendor can provide everything you need to get the job done. And so those who can maneuver and manage that within that ecosystem are the ones that are achieving the greatest scale and tend to move the fastest. And obviously that ecosystem has very strong cybersecurity, infosecurity implications as well, which is, as Joe mentioned in his opening remarks, is very important to being able to scale and to move with some pace.
Awesome, thank you both. Okay, so in terms of next steps, we would love to continue this conversation. If you have more questions, please contact us via the Element website and we'll be happy to discuss further. You can also try Element Unify for free to see how it can work for you. Request your trial on our website or the AWS Marketplace or the Azure Marketplace, whichever one works best for you. To learn more about LNS research, please visit their website. And finally, engage with our speakers and company on LinkedIn. You can follow them and tag them with your comments or questions. And this is your last chance to copy the links in the chat for all these helpful things that you see on the screen. No worries if you don't get a chance to do that. We will send follow-up emails with this information and more. A huge thank you to Joe and Andy for your time today. And
Juanita, thank you. Joe, thank you.
And thank you, Andy. Thank you, Juanita, for setting all this up and involving LNS.
Sure, no problem. And thank you everyone for joining us. We hope you have a wonderful rest of your day. And this concludes the session.